So this part of multi-threading is not really complicated, but it does take a little bit of getting used to because it's not like the usual programs that we write. One of the things we have to worry about is how to handle the completion of a thread. It turns out we really don't have to do anything. When a thread finishes executing its thread function, it doesn't really return. It's just done. And then you can get return values, but it doesn't return to main. You, in the parent, you have to wait for a thread to finish by using this pthread join. So you did a pthread create to start a thread. You don't actually stop the thread just stops, and then you can wait for the thread to finish. And the main reason for doing that is to get the return values. And that is another tricky thing, is that these are things we don't see in programming languages like Java. Now you have a pointer to an untyped pointer. So that's what the star star means. Oftentimes when you see a star star, that's like you can think of it as a two-dimensional array or an array of strings or something like that. But in this case, it's just because you have to return something that you use a void star star. Okay. And the first argument is that struct that you um, passed into pthread create. That should have been modified. That's why you pass in a pointer to pthread create, and then so you get something that's been modified and set by pthread create, and then you pass that into pthread join, and so pthread join knows which thread you're waiting for. Okay, so once again, pthread t is a struct for pthread that's initialized by pthread create, and this is how you identify which thread you're waiting to finish, you're waiting for. You don't have to pass in a pointer. Okay, so here is the tricky one. This is a pointer to a pointer. So you pass in a pointer to something, which is a pointer, that the thread will modify. This is how we can get a return value for the thread function. So the thread function, remember, returns a pointer. And even though the thread itself does not really return to the calling function, what you're going to do is you're going to use pthread join to get that return value. And so you can pass in null if it doesn't, if you're not really returning anything. It doesn't, just because you have a thread function doesn't mean you have to return something. You can just return 0. And maybe you don't care what it returns. You just have it do its work and then it's done. Okay, so here's how you would wait for a thread to return. In this case, we have your main function, you have your thread function, and so here we create the thread. So we say pthread tp, pass in a pointer to p in pthread create, and then we join or wait for that thread to finish by doing a pthread join, and we pass in just the p, not ampersand p. Okay, so let's say we want to get the value in two values from this thread function. So we put that in a struct called myReturn or myret. All right. So you want two things from the thread, x and y int values. Remember, a function cannot really return like two things separately, but it can return an array or a pointer to a struct, things like that. So that's what we want to do here. So we declare m to be a pointer to a struct myReturn. So this implies that we don't notice that we're not allocating memory for p, we're just allocating memory for m. We're just declaring a pointer to a struct. So chances are this is going to be the memory for this is going to be allocated elsewhere, and sure enough, if you look in here, you'll see r is a pointer to that same struct, and the first thing we do is malloc. So it turns out you have to actually put in you have to cast this to be a pointer to struct myReturn here, or you might get a warning, but this should compile and run. you might have to get rid of the warnings, you might have to cast the return value of malloc here. So what do you malloc? You find out the size of this struct my return type, and so yeah, so it looks like this shouldn't be there. Should just be struct myret. And so you get the size of that struct, pass that into malloc, that's how many bytes you want, and then have r point to that chunk of memory on the heap that points to this struct. And then what we do inside this thread function is we set the values. So remember, we're going to use arrow notation in structs in C. So this says, we don't have this in Java, but in C you have to use arrow notation if you're dealing with pointers. And so we set the x value to be one thing, and then the y value to be the argument that we get passed in plus 1. This is just an example. And then here's the thing is we cast that pointer to a struct myret to be a pointer to pointer of undefined type. We have to do that to avoid warnings once again. And we're basically returning R. So let's take the big picture in mind. You have M here. That's what you want to get out of this. You can't just call my thread and get the return value, though that won't work. Right? You have to say pthread is going to have to create a thread with all this stuff like the stack and all of that. And we're going to pass in this argument x, or pointer to x actually. And internally it will get the thing that we passed in as a pointer. It'll get the value that it's pointing to using the dereferencing operator. Allocate space for a struct, set those values in the struct to be m and m plus 1, and now what you want to really do is just return that, but you can't just return the struct back into main. You have to return a pointer, and so here is the key. This will take a little bit of getting used to. So when you do a pthread join, you pass in a pointer to a pointer. We have a pointer to a struct, and so we have to get a pointer to this m value. That's why we need the ampersand here. And then we pass that pointer, and we have to recast it just to avoid compiler warnings. It would probably work without this casting, but just to suppress warnings, we cast it as void star star, means pointer to a pointer, which is what it is because we used ampersand and it's already a pointer. So now we get a pointer to a pointer, and then everything works. So once we get this value back, we can sort of dereference it and look inside that struct m, or the struct that m is pointing to. So you get m.x, m.y. It should just be 0 and 1. Nice simple code. I mean, it doesn't do much, but it shows you how to pass in things and also how to get the return value using pthread join. So this is one, there are many pitfalls, and this is one way not to do things. So you do the same kinds of things. You create pthread, pass in a pointer to p, you pass in a pointer to the function, you pass in the parameters that you want to have pthread put into this thread function. All of that is good, and then you wait for it to finish, you join, you get the return value. But then all of this is fine, all of the main is fine, the struct is fine, but this is the thing that you don't want to do. If you declare R to be of just struct my return, this struct is going to be allocated in the stack, which means that as soon as you return, it's going to pop the stack. This just like and actually it's even worse in that it's inside a thread. It's going to get rid of this because it's in the stack. You're going to when you return, all of the stuff that's in local variables in this function are going to be gone. It's no longer valid. It might work some of the time, but as soon as the stack space that was sort of vacated by this function is used for something else, you can get corrupted values, and it's just not going to work. It's just not, it might work some of the time, and those are the worst kinds of errors where you have something working some of the time but not all the time. So this is another pitfall. The main pitfall is that you're trying to return something that's allocated in the stack. You do not want to do that. You want to have a chunk of memory that's going to stick around beyond the lifetime of this function, and the heap is where you want to do that. Okay, so that's why I'm going to scroll back up, and the fix is to allocate memory for this struct in the heap using malloc. All right, so don't do this. There's a lot of things you should not do. So another thing that you might want to watch out for, you don't want to do this, is if you do something like this, call the myThread function and then pass in some argument. That's because myThread function, you can't pass in x because myThread function takes as an argument a pointer. So let's say you try passing in pointer to x, okay, and then you get the return value, and then you say, well, that return value is a pointer, but I'm going to recast it as a pointer to a struct of type myret. This will work, but you're not creating a thread. So this will actually work fine. You're just calling the function. And sometimes that's all you need to do. You just want to call that function, but often you want to have things run in a separate thread and do its own thing, and then in main you want to do something else. So you can do this, but this is just calling another function. Okay, so turns out this is completely sort of similar to, or it's completely the same effectively as calling the pthread create and then pthread join. So that's why we would say that if you have a combination of a thread create and a thread join, like here you create a thread and then you join, let's say right away, that's completely equivalent to calling that function without using threads. So here we are not using threads, and in here we are using threads. But since if you find yourself writing code like this, where you create a thread and you join right away, you create another thread and you join right away, it's not really multi-threading because you're just essentially just calling the function. Okay, so something to watch out for. Okay, so it turns out the way we'll handle critical sections is we'll start out by using locks, and then we'll take a look at that next.